Welcome back, Algebra 2 Trig students. You're probably sick of hearing my voice. It's Mrs. Leopold. We are in Parent and Piecewise Functions, Unit 6, and Lesson 3. So this is our introduction to piecewise functions. You might be going like, what is a piecewise function? I've heard you say this before. Well, piecewise functions just very much, they're pieces of different functions. And we put them all in one graph. We take different pieces and identify them based on different restrictions of the domain, and we put them all together to make one particular piecewise function. We have a very famous, I guess you could use that word, a very common piecewise function is the absolute value function, because you could think of it as having just two pieces. You could have a part of a line, so really it's a ray with the positive slope, or you could have part of a line or a ray with the negative slope. Right, and we're just kind of breaking it down and just the right-hand side. So the right-hand side has this positive slope. Well, if it has a positive slope on the right-hand side, then we're just going from 0 to infinity. And then with the left-hand side, it has this negative slope. So we would have a negative x here, and that goes from negative infinity to 0. Now, what you might be noticing is that the 0 cannot be contained in each of those pieces. So that 0 needs to be in one or the other section of that domain restriction. You can decide which one you want to put it in. So in other words, we could have made this exclusive and then, still exclusive for infinity, but inclusive here. So if it's inclusive of one for 0, it's exclusive of the other. The 0 can only be in one piece of the equation. So that's what we're going to keep in mind as we go through more specific examples throughout this lesson. So the first example here, graph f of x equals -3 times the absolute value of x minus 2. Then we're going to rewrite the equation as a piecewise function. All right, well, first I would graph it. And hopefully when you're graphing it, you're thinking, well, I need to find the vertex. So the vertex is moving right 2, up and down 0, right? So we don't have a k value, so it's just right 2. And then from this, we have our slope. Our slope is negative. So our slope is -3. And remember, from that vertex, you can go down or up that slope on the right-hand side only. So if the slope is -3, I'm going to go down 3 to the right 1, down 3 to the right 1. So this is half of that absolute value graph. And then we have this reflection over the vertical line that goes to the vertex. And so the other half would just be over here on the left-hand side, the same distance away, that reflection. So there's my equation of that graph. Now, we need to split this into any function that's a piecewise function. So we do f of x equals, and then we need two pieces. We need this right-hand piece, and then we need this left-hand piece. So the left-hand piece I'm going to start with because it's really nice. I have a slope and I have the y-intercept, right? So I have the slope right here. I can see the slope is 3 over 1 or just 3, and this is the y-intercept. I happen to go right through, let's see here, 1, 2, 3, 4, 5, 6. Happen to go through -6. So that's an equation of a line with a slope of 3, a y-intercept of 6. So that's just 3x minus 6. But that is only for the left-hand portion, right, of this graph. So from -infinity, so we're going from -infinity to 2. Then I have the left-hand side. So I'm going to put 3x minus 6. That's the portion of the graph. Sorry, my hand slipped there. 3x minus 6. And then right beside that, I identify what the domain is. And the domain is for -infinity to 2. Now, if I include the 2 here, then I cannot include it in my blue portion of my graph. So the blue portion is going to go from 2 to infinity. Right, so I went from -infinity to 2. That's going to be this purple graph. Then I break it down and I do the other part of the line from 2 to infinity. So now the question is, how do I get the equation of the blue graph? Well, we can continue with that slope up 3 to the right, or sorry, left 1, up 3 to the left 1 to get the y-intercept, which I can see the y-intercept is positive 6, and the slope is negative 3. So if I'm doing the y equals mx plus b thing again, my slope is negative 3, my y-intercept is positive 6, so this time I'm going to get negative 3x plus 6, and then that is only the right-hand side of the equation, so it's going to be from 2 to infinity. Again, just to reiterate, if you include the 2 here, you must exclude it here, or you could have reversed that. You could have excluded the 2 here in the purple function, included it here. It's up to you. Whichever one you decided to do would be fine. So you decide, but this is what I chose to do. I think the answer key in the booklet or in your Google Drive is different. That's okay. All right, so next, it says sometimes piecewise functions will be continuous, meaning you can draw the entire graph from left to right without lifting your pencil from the page. Other times, it will be discontinuous. You're going to have a gap somewhere. You're going to have a hole. You would have to follow along, pick up your pencil, and then go again. So this is a gap right here. This open circle means there's a hole right there. So we could have gaps, we could have holes. It just depends on what is given. So here we have a function. It's a piecewise function because we have 2 pieces. We have this horizontal line here, and then we have part of a line here. It's like a ray. And so question number 1 is h of x, if we're calling this function h of x, is it a function? So does it pass the vertical line test? So anytime I draw a vertical line, does it only hit that function once? And I would say yes, it does. So the most maybe confusing part, or the part that you're not sure about, is right here where you have an open circle and a closed circle. Well, the open circle is open up here and closed down here, so when you draw that vertical line, it does only hit the graph at one particular spot. So is this a function? Yes, because it passes the vertical line test. Is h of x continuous? Hopefully you're saying no. I would follow along, jump down here to the bottom part. So no, it is not continuous. What is the domain of h of x? All right, well, let's look at the domain. So the domain, the leftmost point is negative 3, and the rightmost point never ends. It goes on infinitely. So the domain is negative 3 to infinity. Now, do we include the negative 3 or not? Well, it's a closed circle, so yes, we do include the negative 3, but no, we do not include infinity because that goes on infinitely. What is the range? Well, the range goes from the least y value to the highest y value. The least y value is here at 1. It is a closed circle, so we're including 1. Because this purple graph goes up forever, then the range is not bounded. It goes on to infinity, so it goes to infinity exclusive. Finally, we have here, or not finally, but it says, what is h of 1? So this means, right, h of x, well, they substituted in 1 for x. So if I go to 1, plug in 1 for x, what is my answer? Well, this is where the closed circle is. This is where the open circle is. So naturally, I'm going to look at where the closed circle is. So the ordered pair, or the y value that is associated with the x value, 1 would also be 1. So that answer to part E is 1. Now try to write the piecewise function. The piecewise function, we put h of x equals. We do this little squiggly line. I guess it's just another bracket type of thing. And we're going to have 2 pieces. We have this blue piece right here, and then we have the purple piece. So the blue piece is just a horizontal line. It starts at -3, it ends at 1, and it is always a value of 2. So we call that a constant. So this constant always has a y value of 2. But it starts at -3. It's inclusive of -3 because that's a closed circle there. And it ends at 1. But it's an open circle at 1, so I have to exclude the 1 here. And then I jumped down to this purple graph. The purple graph starts at 1. It's inclusive, and it goes, as you can see, to infinity. But the question is, what is the equation of that graph? Well, I see I have a slope up 1, right 1, up 1, right 1, up 1, right 1. So if I continue down 1, left 1, this is the y-intercept. So I have a y-intercept of 0. I have a slope of 1. So if I'm putting it into this equation, y equals mx plus b, that would be 1x plus 0. So the equation of this line is just simply x. If I put in 1, I get 1. If I put in 2, I get 2. If I put in 3, I get 3. So that is the piecewise function. I have 2 pieces, and then I have to do the domain restriction to identify where those pieces begin and where those pieces end. All right, let's look at example 3 and example 4. This time we are giving you the pieces and the picture of the different parts of the function, and you are coming up with the equation. I guess we just did that as well. So we're going to do it again. First thing you might want to ask yourself was, how many pieces are there? And then when you figure out how many pieces there are, maybe you want to figure out the domain portion first, because that's usually a little easier. And then go from there. So we have a piece right here that is part of a parabola. So that's one piece that I have. So this is the piece of the equation, and then this is the domain. Then I have this second piece here. So yes, it's just a point, but that's important. So I have a point, I have the domain, and then my last piece is this section, which is part of a line. So I have those 3 pieces. So let's do the domains first. That might be easier, right? So this parabola right here, it goes on infinitely to the negative infinity, and then it comes and it stops here at 2, but it's an open circle at 2. So it's exclusive of 2, and of course negative infinity is also exclusive. So I'm going to go from negative infinity to 2. So that is the parabola's domain. Then I have this point. That's kind of weird. That point is just 2, 6. So that's kind of easy to do. The y value will be 2 when the x value, the y value will be 6 when the x value is 2. So really, that's all I'm going to have. I just put the 0.6 there because there's nothing else to do. A point is not an equation, right? You just have a point. So this is the x value of the point. This is the y value of the point. You're done. The last domain restriction, well, we start at 2, but it's exclusive because it's an open circle. And then it ends here with a closed circle, so it's 3, 4, 5, 6. So it ends at the value 6, and it's a closed circle, so I include the 6. So if nothing else on your assessments, if you're stuck with the development of the equations, you can at least do the domain restrictions. That should also be something that you can fill out and earn some points by doing these 3 bits right here. The next part I would say is be identifying what that part of the equation is. So I can see here the blue part is a parabola, the red part is a point we already said, and the purple part is a piece of a line. So a parabola, the parent function of a parabola is just x squared, and then we're going to potentially move the vertex off the center of 0, 0, but actually the vertex is at 0, 0. And then we went right 1, up 1, left 1, up 1, right 2, up 4, left 2, up 4. So there's no stretch, there's no shrink, there's no change. So actually that is just a regular old parabola of x squared, except I've restricted it by going from negative infinity to 2, and it just chops off at 2. We already have our 0.26 listed next. So the final thing I have to do is get this equation of the line. If I look at the equation of the line, my slope is up one, left one, up one, left one, up one, left one, up one, left one. So that is a slope of -1, right? Up one, left one. So that's a slope of -1. And if I continued that pattern, up one, left one, up one, left one, my y-intercept would be what? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My y-intercept would be 10. So putting that in y equals mx plus b form, my m is negative, my b is 10, so I have a negative x plus 10. Notice I only put the negative x plus 10 here. I didn't really address this before. That's because f of x is representing our y, right? So f of x either equals x squared just for this portion of the domain, or f of x just equals 6 for this portion of the domain, or f of x equals negative x plus 10 for this portion of the domain. So that is your final solution. If I were to erase those green marks, this would be our answer right here. All right, so you could try number 4 on your own. Maybe before you try it, we'll just look here together and see what pieces we have. First, I hope you recognize you have 3 pieces. This is a portion of a line. This down here is a portion of a horizontal line. And this over here, hopefully you're saying that is a square root function, right? So you're going to have 3 different pieces of this piecewise function. You're going to have the red part, you're going to have the purple part, and you're going to have the blue part. So go ahead and try this on your own and then unpause to see how you did. So did you get these answers? Right, it's an equation of a line. It has a -1 slope, down one, right one, down one, right one, down one, right one. So my y-intercept would be 0. Slope is -1. So this is what I would get for that equation of a line. It's going from -infinity to 1. It's a closed circle on 1, so that's why I have the inclusive value here. Down here, this is a horizontal line, a constant. The constant goes from -1 to 2. 2 is inclusive, so -1 to 2. It's always going to be a y value of -2. So I just put -2 for that entire portion. And there's my domain restriction based on that. And then I have my blue portion, which we said is a square root, except it's a square root shifted right too. So that's why I have my x minus 2 underneath the square root symbol. And then of course it went 1 to 1, 4 to 2. So there was no vertical stretch. So it's just the square root of x minus 2. And then it's an open circle here. So it's exclusive, and it goes to infinity, so it's also exclusive. Well done if you got that. If not, you're super confused, just stop in and see your teacher, ask questions during class. All right, this next function is called a step function, and hopefully you're like, oh, that makes sense. Those look like steps. So if I was going to write a piecewise function for a step function, it's maybe a little bit easier than you think. We have 3 portions. We have this blue step. Our next step, I'm going to color it red. And then our last step, I'm going to color purple. Notice at the ends of each step, we have a closed circle and an open circle, right? We have a closed circle, open circle. We have an inclusive point and an exclusive point. And the reason it's inclusive and exclusive is so that when we draw our vertical line, it passes the vertical line test and it's still a function, which means we can use this notation right here. So for those 3 pieces, right, I have a domain restriction, I have the actual equation, domain restriction, equation, domain restriction. So the blue portion, well, it's just a constant. It's a constant of -3, so all I do is put -3, and it's a constant from -5 to -2. Includes the -5, excludes the -2. For the red portion, it starts at -2, ends at 1, but it's inclusive at the -2, exclusive at the 1, and the constant value, the constant y value that it's always going to be, is 0. Then I have the purple function. It starts at 1, inclusive, ends at 4. Exclusive because it's an open circle, and those y values that it always is that whole time is 3. So there we have it. That's the piecewise function that represents this step function on the graph. So then the next question says, state the domain of this function. Well, hopefully you're saying to yourself, the domain starts at -5 and it goes and ends at 4, but it's inclusive of the -5 and exclusive of the 4. We end with an open circle, we begin with a closed circle. Now the range is just 3 separate numbers, so be careful here. The range is just -3, 0, or 3, right? We have all the values are at -3, or all the y values are at 0, or all the y values are at 3. So it's not continuous. It doesn't go from -3 to 3. It's just 3 individual discrete numbers. Okay, then it says evaluate f of 1. So f of 1, when I plug in 1 for my x value, well, it's an open circle here, so that's not it. So it's a closed circle up here. So f of 1 is equal to 3. That means when I plug in 1 for x, what do I get? I get 3. Or if I plug in -1 for x, so I plug in -1, what am I going to get? Well, hopefully you're just saying to yourself that's going to be 0. So my y value is going to be 0 when I plug in -1. If you look at this step function, is this step function even, odd, or neither? Justify your answer. So even, odd, or neither. Remember, if your function is even, then that means when you put in the opposite of x, you just get the same y back. So an absolute value function is an example of an even function. If I put in some kind of x value and I get the same y value when I put in an x value, I get a y value. When I put in the opposite of the x value, I get the same y value. That's going to be an even function. It's reflective over the y-axis if you're looking at it graphically. For an odd function, that means when you put in a cubic function is an odd function. When you put in an x, you get a certain y. When you put in the opposite of x, you get the opposite of y. So when you put in the opposite of x, you get the opposite of y. That's an odd function. It has rotational symmetry. If you turn it 180 degrees, you're going to see the exact same graph. So if I rotated this picture and looked at it, would it be the same? No, it wouldn't, because the closed circles would be on the right-hand side, open circles would be on the left-hand side, and those values wouldn't even be the same with respect to 0. If I folded my paper over the y-axis, would I have the graph lay on top of each other? No, I would not. So this is a neither. It is neither even nor odd. You could try it by plugging in x to see what happens, or you can just look at it graphically. All right, let's look at this scenario right here. This is kind of a real world scenario that you or your parents have encountered before, and you will encounter at some point when you're paying the bills. So it says, a doctor's fee is based on the length of time he spends with the patient. For up to 6 minutes, the flat fee is $50. That means if you see the doctor from 0 to 6 minutes, you're just going to pay $50. If you go, or it says up to 6 minutes, so it's just to 5 minutes and 59 seconds. As soon as you get to 6 minutes, from 6 to 15 minutes, the flat fee is $80. And then over 15 minutes, you're going to get charged a flat fee of the $80 plus an additional $5 per minute above 15 minutes. So just have a little moment and think about what that is going to look like if you were to sketch that graph. So what do we have for our x-axis? What do we have for our y-axis? Well, hopefully you're saying to yourself your x-axis is representing time, and that time is in minutes. Your y-axis is representing money. that money or that fee that you're paying the doctor in dollars. So what do we have? We're going 80 or above, so 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Sorry, talking to myself. Here we go. So for up to 6 minutes, the flat fee is $50. So I have 1, 2, 3, 4, 5, 6. Maybe I should have just made that a little easier for myself. We're just going to do 6 minutes, then we're going to do 15 minutes from then on. So for up to 6 minutes, we're going to pay $50. Well, this is $50. So 0 minutes, you know what? If it's 0 minutes, you don't see the doctor at all, you're not going to pay any money. So that's an open circle because I'm not going to pay any money if I don't even see the doctor at all. Then for up to 5 minutes and 59 seconds, I'm going to pay $50 flat. But as soon as I get to 6 minutes, it jumps to $80, right? From 6 to 15 minutes, it's $80. So from 6 to 15 minutes, I've got that fee of $80. After that, what happens? It says over 15 minutes, he charges a flat fee of $80. Okay, got it. We have to pay this $80 plus an additional $5 per minute. So that is going to be a slope, right, of $5 per minute. It's going to increase. Now have a little think about what that is going to look like. Well, we want to start, like when we're going to start that slope is right here at the point 1580. So if you're thinking about that as an equation of a line, usually it's just y equals mx plus b. But I'm going to do a, let's put this mx plus b. I'm going to shift that starting point to the right 5 units, 15 units. So I'm going to put the x minus 15, and I'm going to go up 80 units. So I'm just applying my knowledge about transformations, but it's in a linear form. And the last thing I do is I replace the slope. We just said you're going to have to pay $5 per minute. So instead of having an m right here, you're going to have a 5 in front. So that's my equation of a line. You can leave it like that, or you can go ahead and simplify. It doesn't really matter. We're going to accept both. So if I'm trying to do this piecewise function, notice here we have a t instead of an x, so it's function with respect to time. I have 3 pieces. I have this first piece in blue, so it's just going to be a flat $50, and that goes from 0 to 6, exclusive on both of those parts. Then I'm going to go here to this red portion, and that is a flat fee of $80, and that goes from 6 to 15 minutes, right? So from 6 to 15 minutes, inclusive of both, because at 6 minutes I pay $80, and at 15 minutes I still pay $80. But as soon as I go above 15 minutes, I'm going to use one of these 2 equations. So because I went and simplified it, I'm going to go ahead and put 5x plus 80. But you could have written this equation here instead if you wanted to, if you didn't simplify. But that begins as soon as you go 1 second over 15 minutes, and then you go infinitely beyond that. Or do you go infinitely beyond that? Well, that's a good question. So it says, if you were there for 12 minutes, what would the fee be? Well, hopefully you're saying to yourself, this is when x equals 12. If x equals 12, how much would the fee be? It would just be $80. If you were there for 20 minutes, what would happen? Well, we went 20 minutes. It's out here somewhere. We're plugging in our x. Our 20 minutes is in this category right here. So what do? We put in our 20. And so, oh, my bad. I see a little error here. You guys are probably like, wait, Mrs. Leopold, what are you doing? Negative 75 plus 80 is not 80. It should be plus 5 right here. My bad. So that should be 5x plus 5, instead of 5x plus 80. I don't know why I wrote the 80 twice. So minus 75 plus 80 is plus 5. So anyway, 20 minutes. This is saying when x equals 20. Well, x equals 20, this is the part of the domain where x equals 20. So I'm going to put 5 times 20 plus 5. So that would be $105. So that's how much you would pay if you were there for 20 minutes. And lastly, we didn't really mean to trick you here, but you do need to pay attention. This has a domain restriction of 18. So instead of going to infinity, that's why I said, or is it going to infinity? Well, it's really not. It says to go through 18 and be inclusive. So if I went through 18 and I was inclusive, it would just end here and I would only have this portion of the graph and I would no longer have any of this blue part going on infinitely, right? So this would just be 5x plus 5, and then we would go from 15 to 18 only because we told you to stop the piecewise function at 18. So hopefully that makes sense. Otherwise, if we wouldn't have made that statement up there, it would have gone on to infinity, although no doctor is going to stay in his office infinitely and just charge you a certain amount of money. Okay, moving on to example 7. It says graph the following functions and state the overall domain and range for the function. So this time we're giving you the equation and you have to take those equations and graph them on this graph over here. So I'm going to color coordinate. I'm going to do this first portion as purple and the second portion as blue. So the first portion is an equation of a line, and the equation of a line where we have y equals mx plus b. So we go up 2 units and then we have a slope of 1. So I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And then I have to pay attention to what my domain is. Oh, darn. My domain is actually less than 1, so I have to go the other direction. So down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. So the other thing I need to pay attention to is that this is an exclusive value. So it's going to be an open circle at 1 and going down and to the left. So that's the purple portion of the graph. The blue portion of the graph is an equation of a parabola, and this vertex of the parabola is 1, 0. So I go to the right 1, up 0. My bad. It's including this value of 1. So I'm going to put a closed circle here, and then I'm only going to the right because this is from 1 to infinity. So I'm going to go right 1, up 1, right 2, up 4, and I'm going to infinitely go open my parabola going to the right infinitely. So this is the piecewise function that represents this function over here on the left-hand side. So that's the graph that represents that function. If we're asking you what the domain is, well, the domain, this arrow goes on infinitely, this arrow goes on infinitely, and at 1, it is actually defined. So your domain is just all real numbers, or from negative infinity to infinity. Your range as well, it goes down infinitely, it goes up infinitely. So no matter what y value you look at, you're going to have some kind of x value associated with it. So our range goes on infinitely. So from negative infinity to infinity. Okay, looking at letter B, I would pause and try this one on your own. See how you're doing with the different pieces. You can see here we have a square root function, but only this portion from -5 to -1. And then we have an absolute value function, and that goes from -1 to infinity. So pause and try this on your own and see how you do. All right, is this what you got? So I separated the red part and the blue part. The red part is a square root function. So first I had to find the vertex, which is left 5 down -4. So I got this point here as the vertex. Then I have a vertical stretch of 2. So instead of going right 1, up 1, I went right 1 up twice as far. And then usually we go to the right 4, 1, 2, 3, 4, and we go up 2, but I had to go up twice as far. It's inclusive of the -5, inclusive of the -1, so both of these have closed circles, and so that is why I have that red portion drawn like that. The blue portion is a absolute value graph, and so my absolute value graph has a vertex of 1, 0, and so I started here at my vertex of 1, 0. The slope is just a 1, right? That invisible 1. So to the right of it, I just have a slope of 1. And then, of course, I reflect it over this vertical line. So I have a slope of -1. But I start at -1 with an open circle because it's exclusive, and I go to infinity. So there's my absolute value graph. Now, taking those two graphs, I'm looking at the domain. The domain, the leftmost point is -5. It's inclusive, so I have inclusive. And then it goes on to infinity with my rightmost point. With my range, my lowest point is -4. It's inclusive, and then it goes on infinitely upward, so I have my infinity. And again, letter C, I would go ahead and pause and try this on your own. Do similar to what I just did. See if you can do it on your own. So I'm going to color coordinate. I'm going to make the first one red, the second one blue, the third one purple. Then I'm going to graph at -2. It goes only to -4. So I have that from -infinity to -4, inclusive at the -4. My blue part is a line. That line starts at +2, and it has a +1 slope, but I'm only going from -4 to 1, so I need to draw that line from -4 to 1, stopping at 1, inclusive of 1, exclusive of the -4, but that's why I have the red dot there at -4, because it was inclusive of -2. My purple portion is a parabola with a vertex of 1, 2. I go to the right one up 2. It has a negative stretch value. It's also exclusive at 1, so I have to do an open circle. Negative means it goes right 1 down 1, right 2 down 4, right 3 down 9. And that goes on infinitely because that's for all values greater than 1. What is my domain? My domain is from -infinity to infinity. And my range is from -infinity to 3, inclusive of 3 because there's a closed circle up there. I hope that makes sense. Ask questions to your teacher if you're not sure what's going on. Okay, we're almost done. Example 8, same idea. Write the equation for the following function. I'm going to color coordinate. I'm going to make a purple section that looks like a square root to me that's been flipped upside down. It's been reflected over the x-axis. And then I'm going to do this one, color coordinate. This one looks like an equation of a line. So I would go ahead and pause, try this on your own, see how you do. We're going to have f of x equals, we're going to have two sections. I'm going to have my purple section, and I'm going to have my red. Let's go ahead and pause and try it on your own. All right, did you get what I have over here? I have my purple part and my red part. Both of these were tricky. So have a look and see if this is what you got. The purple part is a square root function, but it's been reflected twice. So typically your square root function looks like this, right? And then if we reflect it over the x-axis, it's going to look like this. And then if we reflect it over the y-axis after that, right? So reflection over x, reflection over y. So that is how I get my green portion. So I had to reflect it over the x and then reflect it over the y. So both of those reflections needed to be there. That was the tricky part. Otherwise, you just find your vertex. This is your vertex here. And so then I put in those transformations into that function. So my purple portion was the negative square root of the negative quantity of x minus 1 and then plus 3. And of course, that went from -infinity to 1 inclusive because that was a closed circle up here. So if you decided to write that as -x plus 1 plus 3, that's fine. It didn't really matter, just as long as you know there was a double reflection there. And then the red portion was also tricky. That was an equation of a line with not an obvious y-intercept. So we had to figure that out. So the easiest way to figure that out would be to set up that y equals mx plus b line and say to yourself, hey, this is our starting point, and take it based on what we know from our transformations. And then not only is that our starting point, then we have our slope. So I substitute in my slope for m, and then I take that x value and I move it to the right one because that's where my starting point is at 1, and then I go up 4. That's now my new quote unquote b value. I just shifted the graph up 4 units. Then I distribute, so I would get this equation. After I distribute, I get negative 2/3 x plus 2/3 plus 4. Then I can just keep it as this. I could have inserted up there, or I just made this, 3 times 4 plus 2, which is 14/3. So either one of those things up there, my equation could have been this negative 2/3 x plus 14/3, or if I wanted to put negative 2/3 x plus 4 2/3 right there, that would have been fine as well. But this is my equation of that piecewise function graph. And finally, we have our closure, putting it all together here, just see how you do. We have some graphs over here on the right-hand side. That's our piecewise function f of x. We have pieces for each one, and go ahead and pause and try to answer these questions on your own, and then compare it with my answers as soon as you're done. All right, check your answers. You have your values, hopefully A through E or A through G is pretty straightforward. Even the increasing intervals and decreasing intervals, where they have the purple highlighting, that's where your increasing intervals are, where your decreasing intervals are. Where the constant is a constant, remember, is just a horizontal line like this. There are no constants, right? We don't have any horizontal lines going from left to right, so that's why it says never. And then the equation. So each part, there were 3 different equations. The green one, the green highlighted portion right here, the equation of the line was probably the hardest, right? So you might have seen from this, you went up 3 to the right 2, sorry, to the left 2, up 3 to the left 2, so that gives me a slope of negative 3/2. Then my starting point is left 2, down 5, so I went left 2, down 5. Then I just distribute to get my equation of my line. That's from negative infinity to negative 2. Closed circle here, so inclusive of the 2. The next section was an equation of a parabola, except it's upside down, so I have to have this negative in front. All I did was shift the vertex to 0, 2, and then I stretched it and I flipped it, so I stretched it twice as far. So instead of x squared plus 2, it's negative 2x squared plus 2. Open circle, closed at the 2. And then after that, for this last one, I guess I'll do in purple, this is a square root, right? Where the square root's vertex was at 2, negative 6. So I have 2, negative 6. And it's just that 1-to-1, 4-to-2 relationship, so no stretches. But if I included the 2 here, I need to exclude the 2 here. And then, of course, it goes through the graph, which implies it goes to infinity. So this stuff is not easy. You just need to review all of your graphs, keep practicing, and make sure you ask questions and stay on top of things. Don't wait until the last minute. Good luck. Bye.